Resilience to Alzheimer's Disease with Dr. Laura Zahodne.
So tonight we're very fortunate to have Dr. Laura Zahodne present some of her work as well as other work in the field of Alzheimer's disease. Laura is a clinical neuropsychologist. She received her undergraduate degree from right here from the University of Michigan, yay, and her PhD in psychology from the University of Florida. She then went on to do a postdoctoral fellowship at Columbia University in Manhattan. So Laura is now an assistant professor in the psychology department here at the University of Michigan. So the main objective of Laura's research is to understand how social experiences influence late life cognitive function, as well as the manifestation of neurodegenerative diseases. So tonight, Laura's talk is entitled Resilience to Alzheimer's Disease. Please join me in welcoming Dr. Laura Zahodne.
Thank you. Thank you very much for everybody for coming out tonight. I'm impressed that we have such a large crowd given how many other better events are going on. Thanks also to the organizers of the speaker series, Chris and Tim. It's really an honor for me to have this opportunity to present to you all some information on a topic that's so important to me and probably important to many of you as well. So specifically tonight, I'm going to be talking about Alzheimer's disease, what we do and what we don't know about what it is and how to treat it. But most importantly, I'm going to be sharing tonight some of the exciting research on Alzheimer's prevention, what we might be able to do as individuals and as a society to make ourselves and our communities more resilient to this disease. So many of you might already be aware that our country is aging rapidly. So these charts here show the breakdown of the U.S. population since the year 1900 into 5-year age bands. So you can see at the top left here in 1900, the majority of people in the U.S. were concentrated in these lower bands. So most people were children or young adults. But over time, with advances in medicine and lengthening life expectancies, there's been an equalization of this distribution. So there have been sort of an equalization of the proportions of Americans in these different age groups. So these charts are starting to look more like a skyscraper than the pyramid that we saw back in 1900. So this last panel here, this shows the projected or expected demography of the U.S. in the year 2030. And what's really notable here is that by the year 2030, 1/4 of the entire U.S. population is going to be age 65 or older, 1/4. So clearly, researchers are paying more attention to this segment of the population. Now, while it's wonderful that Americans are living longer lives, one consequence of this demographic phenomenon is that there are and will continue to be more cases of Alzheimer's disease. And so that point is made clear in graphs like this one. This shows changes in the causes of death between the year 2000 and the year 2014. So as you can see, in that 14-year period, we've been able to reduce mortality due to diseases such as cancer, heart disease, stroke, and HIV. But partially as a result of that progress in treating these chronic diseases, more and more individuals end up surviving those diseases, aging, and dying from diseases like Alzheimer's disease. So this is one reason why healthcare providers and patients and researchers are paying a lot of attention to Alzheimer's disease. So how common is Alzheimer's disease? Well, for women who live to the age of 65, there's a 1 in 6 chance of developing Alzheimer's disease. For men who live to age 65, there's about a 1 in 11 chance. So currently in the year 2017, there are over 5 million Americans living with this disease. And as you can see, that number is on the rise and is expected to double just over the next 20 years. And partially this is because of advances in curing other diseases and also in lengthening life expectancies. So now that I've sort of conveyed to you how big of a problem Alzheimer's disease is for our society, let's talk a little bit about what we think Alzheimer's disease is. So one question that I often get is, what's the difference between Alzheimer's disease and dementia? So I created this figure to hopefully clarify some definitions. So dementia is a broad umbrella term for a collection of clinical symptoms. And those symptoms include progressive declines in both cognitive abilities, so things like memory and language, as well as functional abilities, so things like driving, getting dressed, making a meal. And importantly, this clinical syndrome of dementia is not a normal part of aging. So these are separate entities. In fact, the vast majority of people, upwards of 85% of people, will never experience dementia. But among those who do experience these changes in cognitive and functional abilities, we have learned that these symptoms can be caused by many different types of diseases. So some of the diseases that cause dementia can be classified as neurodegenerative. So this is a term that just refers to the gradual loss of brain cells. Other diseases that cause the symptoms of dementia are classified as vascular diseases, and this term refers to damage to the blood vessels that bring oxygen and nutrients to the brain. Alzheimer's disease, then, is one specific type of neurodegenerative disease. So it's a disease that leads to the loss of brain cells and causes the symptoms of dementia. But it's important to note that most individuals who suffer from this clinical syndrome of dementia usually have some mixture of neurodegenerative and vascular pathologies in their brains. So this is one reason why it's been challenging to study Alzheimer's disease, because usually dementia is not one single disease. So I've already talked about how common Alzheimer's disease is. Dementia of the Alzheimer's type typically appears very late in life, so usually in one's 70s or 80s. And the core cognitive symptom of Alzheimer's disease is an impairment in episodic memory. So this is the type of memory that's involved in learning new information and remembering recent events. So by recent events, I mean things like, what did you have for breakfast this morning, or who came to visit you yesterday? Now, as the disease progresses, other cognitive domains can become affected. So people can start to have thinking problems in domains of cognition other than just episodic memory. So for example, people might start to have difficulty orienting themselves to time and to place, understanding and producing language, organizing information, and planning. Interesting though, one of the most challenging symptoms of dementia isn't these hallmark cognitive symptoms, but rather the behavioral symptoms that can appear over the course of the disease. So in addition to these cognitive symptoms, we can also see things like severe changes in mood or depression, agitation or irritability, as well as delusions, which are false beliefs, things like paranoia. And often caregivers and family members will report more distress over these behavioral symptoms than the cognitive symptoms. So what does Alzheimer's disease look like in the body? What is the underlying pathology that causes this disease? Well, the current understanding is that it involves plaques and tangles. So plaques and tangles are abnormal clumps of proteins that form either in between brain cells, in the case of plaques, or they form inside individual brain cells in the form of tangles. So these plaques and tangles are thought to cause the symptoms of dementia. We're not perfectly certain at this time how plaques and tangles relate to each other. So one leading theory is that the plaques in between the cells form first and somehow lead to the formation of tangles inside of cells. And then together, plaques and tangles interfere with normal cellular function and lead to cell death. But these are all very active areas of basic science research in Alzheimer's disease. Now, one reason that this basic science research on Alzheimer's disease is relatively young compared to some other diseases is that until fairly recently, the only way we've been able to measure and study these plaques and tangles is by looking at brain tissue under a microscope. And the only way we could do that was through an autopsy, so after someone has passed away. So it's really only recently that we've been able to develop methods of measuring and studying these plaques and tangles in living people. So for example, a lumbar puncture is a medical procedure, it's also called a spinal tap, in which a sample of cerebral spinal fluid is taken from the back. So cerebral spinal fluid is the fluid that your brain and spinal cord are floating around in. So we can measure plaques and tangles through cerebral spinal fluid. Another more recent way of measuring plaques and tangles in living people is through functional neuroimaging, so specifically a PET scan. So recently, these chemical compounds have been developed that can stick to the individual proteins that make up those plaques and tangles. So in the case of plaques, those individual proteins are called amyloid, and in the case of tangles, those individual proteins are called tau. So these different chemical compounds can stick to either amyloid or tau, and then a scanner, this big plastic machine here, can be used to visualize where in the brain these chemical compounds are sticking. So where in the brain there might be high levels of amyloid or tau. Now, because it's only fairly recently that we've been able to dynamically measure and study the underlying pathology of Alzheimer's disease, the drugs that are currently FDA approved to treat Alzheimer's disease don't actually target the underlying pathology. Rather, these drugs were developed to target chemicals in the brain that help cells communicate with one another. And this is because one of the problems that's caused by plaques and tangles is interfering with cellular communication. So these drugs are really designed to treat a downstream effect of the pathology. And because they're treating a downstream effect of the pathology, they have limited clinical benefit in terms of treating some of the symptoms. They don't actually slow or stop the underlying disease process. But ultimately, that's the goal in drug development research, is to find a drug that can stop, slow, or reverse the progression of Alzheimer's disease. So right now there are many clinical trials going on trying to develop a new drug that treats the amyloid and tau neuropathology of Alzheimer's disease. So this is sort of a confusing slide. This is a cartoon that shows how plaques and tangles are formed in the brain. I just wanted to show it to you to make the point that researchers who are developing new drugs are actively pursuing drugs that target multiple parts of this pathway. So as one example, some drugs are being developed to prevent the production of amyloid. So they're trying to stop amyloid plaques from forming in the first place. Other drugs are being developed to promote the clearance of amyloid. So these are drugs that are designed to get amyloid out of the brain after it's formed. Still other drugs are targeting tau, which again, we think that tau tangles are caused by amyloid plaques. So we have clinical trials going on currently that are attacking each of these different components of the pathway. Now, unfortunately, in the past 10 years or so, hundreds of compounds have been developed and tested targeting this underlying Alzheimer's disease pathology, but so far none of them has been very successful. But one reason that some researchers think this may be is perhaps we're using those drugs too late in the disease process. So those drugs have been treated in people who are already showing symptoms of mild and moderate Alzheimer's disease. And if you give a drug that's designed to eliminate plaques and tangles to somebody who's already showing Alzheimer's disease, that person, by the time they start showing symptoms, has already experienced a lot of cell death, and the drugs aren't designed to bring the cells back. The drugs are just designed to stop amyloid and plaques in the future. So at best, these drugs could stop the disease process. So many researchers have thought that maybe these drugs that target amyloid and tau would be most impactful earlier in the disease process, before individuals develop the symptoms of dementia. So in fact, a lot of the clinical trials that are going on right now are recruiting people who do not yet have symptoms of dementia. So these are folks that might have Alzheimer's disease in their brains. So for example, they have high levels of amyloid on a PET scan, but they're not yet showing those cognitive and functional changes characteristic of dementia. So they're in a sort of a preclinical state. And so the goal with these new trials is to stop those individuals from developing the symptoms of dementia in the first place. So kind of the take-home message from the drug development world at this time is less sensational than some media outlets would suggest. But again, these are very active areas of research. So I want to tell a different story from the drug development story tonight. The story I want to tell really gained some traction this past summer after the annual Alzheimer's conference that happens in July. So every summer there seems to be at least one major headline that comes out of that conference. And this summer the major headline had to do with prevention. So specifically, an expert review group presented a paper at that conference reviewing all of the research that has been conducted to date. And their conclusion was that about 1/3 of dementia cases are preventable, the same way that heart disease and stroke are preventable in many cases. So not every case of dementia, but a sizable proportion of dementia cases may be preventable. So this figure here depicts the life course that we all travel through, so from early life through midlife into late life. And every line in this figure corresponds to an identified risk factor for dementia. And those lines that are in colors, the blues and greens, these are risk factors that are modifiable. They're risk factors that for some people may be avoided through behaviors or through lifestyle choices. So for the majority of my talk today, I'm going to be presenting evidence for the impact of some of these behaviors and lifestyles on dementia risk. So this is a very simplified model of dementia risk in which the pathological changes of Alzheimer's disease, so the plaques, the tangles, and the loss of cells, leads to the symptoms of dementia. And the most prominent symptom of dementia is memory impairment. So in this model, one potential pathway to resilience is to prevent or slow the formation of brain disease. And the first resilience factor that has high potential to stave off brain disease is physical activity or exercise. So here I'm showing the results of a clinical trial. This was a large clinical trial of about 2,000 people that were randomly assigned to either an exercise group, so a group in which people engaged in walking, lower extremity resistance training, and balance exercises, or they were randomized to a control group that involved just passively learning about health issues. Now, like I said, this was a large trial, but here I'm just showing you data from a neuroimaging sub-study. So some of the people in that larger trial underwent brain scans before and after they participated in this 2-year-long exercise study. So as you can see, the people in the exercise group, for many of them, they showed an increase in the size of their hippocampus. So the hippocampus is a brain structure that's central to memory function, and it shrinks in dementia. So for some individuals in the exercise group, their hippocampi got bigger. And if you look at how much people in the exercise group exercised, you can see that those who attended more of their exercise sessions, so those who exercised more, enjoyed a bigger boost in brain size. So some evidence here that exercise is brain protective. Now this is a different study, so some more data looking at exercise and brain disease. This was a laboratory study of rats. So here I'm showing you levels of amyloid that were found in the brains of rats who either were sedentary, so these are rats that didn't move around for much of their lives, versus rats who engaged in regular exercise. So as you can see, animals who exercised showed less amyloid than animals who were sedentary. Now, since we're talking about a study that involved animals, I thought I would mention another reason why basic science research on Alzheimer's disease is younger or relatively underdeveloped than some other diseases. And that's because rats don't get Alzheimer's disease. So in the wild, rats don't express amyloid, and they don't show a clinical syndrome akin to the dementia that we see in older people. So if researchers want to study an animal model of Alzheimer's disease, they have to modify the animal's genetic makeup to make them start expressing amyloid and develop a dementia-like syndrome. So this is an artificial model of Alzheimer's disease. So that might be one reason why some of the drugs that have been very effective in clearing amyloid and treating the symptoms of dementia in rats have been less effective in people, that there are really different diseases that are being treated. So these two studies on exercise and brain disease are strong evidence that exercise is brain protective, but these are just two studies I picked because they were published in the last couple of months, so all within the last 6 months. But there's actually a very healthy literature going back several years about the brain protective effects of exercise. So pretty strong evidence base right now that exercise is brain protective. It's good not just for your heart, but for your brain. Now, the other resilience factor that seems to have high potential to influence brain disease is what we eat. So many different macronutrients, things like fats and carbohydrates, have been studied in relation to Alzheimer's disease, but I think that some of the most compelling studies have been those that have looked not at these individual dietary components, but rather patterns of dietary habits, so combinations of foods. So right now there have been several large studies that have shown a reduced risk of dementia among people who follow a Mediterranean-style diet. So Mediterranean diet is one that's high in plant foods, so things like fruits and vegetables and olive oil. Involves a moderate intake of dairy, fish, and poultry, and a relatively low intake of red meat and sweets. So individuals who follow this Mediterranean diet have a lower risk of Alzheimer's disease. Here I'm showing you a study that happened to include neuroimaging. And you can see that people who reported eating the Mediterranean-style diet, people in light blue here, had bigger brains, both overall, if you look at the whole brain on its own, or if you break it up into gray matter or white matter, which are different types of brain tissue. So these are data from a different study now that's looking at amyloid levels in people. So this is a study that used PET scans to measure amyloid. And you can see again that people who reported eating a Mediterranean-style diet had lower levels of amyloid than people who did not eat a Mediterranean-style diet. But this slide kind of gives me the opportunity to share another important point about the difference between reducing dementia risk and eliminating dementia risk. So here in a picture like this, each red dot here corresponds to one person. And you can see that on average, the group of people who reported eating the Mediterranean diet had lower amyloid. But even within that group, there were several individuals who showed amyloid levels that were really more similar to amyloid levels seen in people who didn't eat a Mediterranean diet. So it doesn't seem to be the case that eating a Mediterranean diet will guarantee that you won't express amyloid. So it appears more to lower your risk than to eliminate it altogether. So if diet and exercise are both things that are brain protective, it follows that having both together may be even more brain protective, and that does indeed seem to be the case when it comes to Alzheimer's disease risk. So this is another study here looking at people who reported both eating a Mediterranean diet and exercising. So those are people in this top heavy black line. So over the course of this 12-year study, those people who both exercised and ate a Mediterranean-style diet, more people in that group remained dementia-free over the course of the 12-year study. People who reported eating a Mediterranean diet but not exercising, those are people in this middle dashed line, they showed somewhat higher risk of dementia. And those people who reported not exercising and not eating a Mediterranean diet had the highest risk. So the fewest members of this group remained dementia-free over the 12-year study. So just to summarize sort of where we are at this point, I've talked about a couple of different resilience factors that appear to be brain protective. I elaborated on diet and exercise, but you should also know that there's strong evidence that abstaining from smoking is also good for your brain, not just good for your lungs. And I want to present now another pathway to brain resilience. So here I'm showing you pictures that you could see in any textbook on Alzheimer's disease or neuropathology. These are two cross-sections of brains from two different individuals who were examined at autopsy. And you can see that one person, this brain on the right, showed high levels of amyloid pathology in their brain. Another individual, shown on the left, showed virtually no amyloid pathology in the brain. But what if I told you that this person on the right never showed symptoms of dementia in life? So even though this brain was filled with Alzheimer's disease, this person never experienced dementia. And it turns out that this mismatch between how much disease is in your brain and what your level of functioning is, this mismatch is not uncommon. In fact, up to 2/3 of older people who never show dementia symptoms in life are found to have Alzheimer's disease in the brain. So this is an important point because it proves that you can have Alzheimer's disease in your brain and never suffer from dementia. So I think that's an important thing to repeat, that you can have Alzheimer's disease in your brain but never suffer from dementia. I think that's important because it sort of opens up an alternative pathway to resilience. So far we've talked about one pathway to resilience involving engaging in behaviors that are brain protective, avoiding the underlying pathology. But this alternative pathway is even if you aren't able to avoid brain pathology, and indeed many people develop brain pathology even though they lived extremely healthy lives, even if you're not able to avoid brain pathology, you may still be able to lower your dementia risk or postpone the onset of symptoms and maintain your memory function in the face of brain disease. So let me tell you about a few resilience factors that appear to operate through this pathway, weakening the link between brain pathology and memory impairment. One of the first studies that identified a common characteristic of people who were able to resist the full functional impact of brain disease was published by a mentor of mine at Columbia University. So here I'm showing you 3 brain scans from 3 different people. All 3 of these people were matched on their level of cognition and function. So they had the same level of symptoms, but they had different levels of education. So the person on the bottom did not finish high school, the person in the middle received a high school diploma, and the person on the top continued on to college. And in this picture, the color blue indicates brain disease. So what you see is that the person with the most education has the most brain disease. So remember that these 3 people were matched on level of symptom. So what this means is that this person on the top was able to maintain that same level of cognition and function despite having the most brain disease. So this person was able to resist the full functional impact of their brain disease. And indeed, education has been one of the most consistent predictors of resilience in older people. Here I'm just showing you one study that I conducted several years ago where we followed a large number of older people with a wide range of educational ability, including quite a few people who had 0 years of formal education. And what we found over the course of this 20-year study was that those individuals with the most education, so it's that top solid black line here, more people in that group were able to remain dementia-free over this 20-year study period compared to individuals with less education. Now, interestingly, similar results have been reported for social integration. So in this picture, individuals with small social networks are shown in blue. So here, small social networks are being defined as interacting with 2 or fewer friends or family members every month. So 2 or fewer friends and family members every month. So those individuals with relatively small social networks showed a negative relationship between brain pathology and cognition. So the more pathology, the worse their cognition. So that sort of makes sense. But what was interesting in this study was that people with large social networks showed a different relationship. So in this picture, large social networks correspond to interacting with 13 or more friends and family members every month. So people who interacted with 13 or more friends and family members every month showed no relationship between pathology and cognition. They were able to remain at the same level of cognitive ability even if they had the highest level of brain pathology. So this is evidence that social interaction, which is both mentally engaging and emotionally rewarding, might buffer against the impact of brain disease. So another potential resilience factor is the extent to which people engage in cognitively demanding leisure activities. So this is kind of a jargon term. What are cognitively demanding leisure activities? Well, as I came in today, I can tell you that many of you were engaging in cognitively demanding leisure activities when you were reading. So reading is a great example of a leisure activity that engages your mind. Other cognitively demanding leisure activities are things like playing a musical instrument, learning a new art form, something that engages your mind and challenges you. So here I'm showing you an analysis of many different studies. So here every dot corresponds to a different published research study that included hundreds or even thousands of people. And dots that fall to the left of this vertical line, those are studies that found a lower risk of dementia among people who engaged in cognitively demanding leisure activities. And any dots that fall to the right of that line are studies that found a higher risk of dementia among people who engaged in cognitively demanding leisure activities. So what you can see is that the weight of the evidence suggests that there is a negative relationship between engaging in cognitively demanding leisure activities and risk of dementia. So here's an example of an intervention study that was inspired by that observational evidence. And here, older people were randomly assigned either to learn a new challenging and engaging hobby, either quilting or digital photography, or they were randomly assigned to a control group where they did not learn a new hobby. And in the chart on the left, you can see that people who engaged in quilting or digital photography, these are people shown in orange before and after they learned the hobby, those individuals showed improvement in memory. So even though they weren't practicing memory, they showed an improvement in memory. And people who did not learn the new hobby in the control group, shown in blue, showed a little bit of an improvement, probably due to exposure to the test, so having practiced the test before, but less of an improvement than those who learned the new hobby. And in the picture on the right, you can see that those individuals who learned quilting or digital photography, these are shown on the right here with the 3 different colors, before, after, and then 1 year later. These individuals showed enhanced brain activity after learning that hobby, and that enhanced brain activity was maintained a full year after they discontinued this program of learning their new hobby. And indeed, research suggests that looking at activities that might be protective against dementia, the ones that have the highest potential to build your resilience to dementia are activities that are new, so not things that you've been engaging in your whole life, activities that are challenging, so not things that you can do on autopilot, and activities that are engaging, so things that are enjoyable and that you find rewarding and that really keep your attention naturally. So activities that are new, challenging, and engaging seem to have the highest likelihood of improving your dementia resilience. So another example of a program that has promoted activities that are new, challenging, and engaging to reduce dementia risk is the Experience Corps project. So Experience Corps is a program in which older people volunteer in the public school system to help kids with reading and homework. And what researchers found in evaluating this program is that not only did the kids do better in school, but the older adult volunteers also showed memory improvement. So here, people who engaged in this volunteer program are shown on the left. You can see that their memory before and after volunteering in the public schools got better. Individuals who did not participate in the program, volunteering in schools, they showed a normal degree of age-related memory decline. So this is a program that was so successful. It started as a research project out of a university in Baltimore, and it has since merged with AARP. And AARP has rolled out the Experience Corps program in 22 different U.S. cities. So Chicago and Cleveland, I think, are the closest ones. We haven't had a program yet here in Michigan, but this is a really creative way of building older adults' resilience while also having a broader community impact. So I want to summarize now our different pathways to dementia resilience. Remember that one way to build your resilience is to engage in lifestyles that protect your brain. Another way is to engage in lifestyles that can help you maintain your cognition and your function even in the face of brain disease. Now, unfortunately, we've not been able to figure out how to guarantee that somebody will not get dementia, so these are all ways to lower your risk, but not to eliminate your risk. And I think another point is that all of these factors I've been talking about today are individual level factors. So these are things that you as individuals can engage in to lower your own risk. But dementia, like other diseases, occurs within a larger social and environmental context. And this context influences not only individual risk factors for disease, but also how easy it is for individuals to engage in these healthy behaviors. So let me show you what I mean. This is one way of visualizing the importance of context. So here you can see one individual attempting to manage his own dementia risk, to push this rock forward. And interventions or prevention efforts that are targeted to the individual are essentially designed to make this individual stronger or better able to push that rock. But as you can imagine, personal strength is only one factor that determines how easy it is to push this rock. Another important factor is how steep the hill is. And individuals who are living in disadvantaged contexts, so contexts that include areas of concentrated poverty, unsafe neighborhoods, lack of healthy food options, poor air quality, individuals living in these disadvantaged contexts are facing a much steeper hill. And interventions or prevention efforts that are targeting the individual can only help so much. We may see broader or better improvement if we have societal or community level efforts to level this hill. And in the US, social and health disadvantages are racially patterned. So here I'm showing you data from the study that I work on in New York City. And what you can see here is that African Americans and Caribbean Hispanics are more likely to develop dementia. So they're at higher risk of dementia. And study after study has shown that these differences in dementia risk are linked to underlying social disadvantages. So one form of social disadvantage that I've been studying in my research is discrimination or unfair treatment. So here I'm showing you data from a study of 10,000 adults who live all over the country. And in that study, Black participants reported more discrimination or more unfair treatment. Here's an example, compared to non-Hispanic white participants. And this unfair treatment, in turn, was associated with negative mental health outcomes. So some examples of those negative mental health outcomes are shown here. In addition, that unfair treatment was also associated with negative cognitive health outcomes in the form of greater memory decline with aging. So some evidence here that lowering social disadvantages may also help to eliminate or reduce health inequalities and make our societies more resilient to diseases like Alzheimer's. So here I'm showing a more complete model of things that we've talked about so far, our individual level pathways to dementia resilience, as well as this sort of broader social structural context. So I hope today that I gave you some information that gave you a sense of the scope of research that's going on in this area, as well as some specific information about how you and your communities may be able to reduce your dementia risk and improve your dementia resilience. And I just want to thank you all again so much for turning up today and for the attention. Thank you very much. Thank you very much.